Good afternoon, ladies and gentlemen. It's my pleasure to be invited here for the second time, and my great honor to represent HST. I am responsible for the international project in our company, and I would like to present this afternoon the topic future-oriented equipment and management systems for the urban drainage infrastructure. Actually, I divided this little presentation in two parts. The first part will deal more with the software management system, a concept. I would like to present a concept, and the second part is more about the intelligent machinery and equipment that allows this management. So if we look at a future-oriented drainage infrastructure, we may divide it into various levels. There is first, I start from the bottom line, the level of the object. So in a drainage infrastructure, we have retention tanks, we have pumping stations, we have a collector system, and so on. Second and the third level, in these objects, there are equipment, technical equipment installed, but first and foremost, also a lot of sensors and actors that measures the actual situation in the structure. The second level is then the local controls and the telematic that transfers the signals coming from these sensors to the higher level management platform, which was the highest level, and this is a combined platform containing of rainfall portal, SCADA process control system, operational system, and probably also a simulating software. When looking at infrastructures, there is one major challenge, which are the peak loads. No infrastructure can be designed for the 100 years rain event or a 50 years rain event. It would be simply not economically. And this is valid for all, more or less all infrastructures, for the traffic, for power, for water supply, and first and foremost also for drainage system. So that means the solution is to create storage. So all this to accept and to take the peaks, but not only to create the storage, but also to manage the storage in the proper and in the best possible and effective way. Another major inflow or incoming system parameter is the precipitation. To know where, when, and how much rain is going to fall is a very, very crucial information that can be and has to be used to manage and to organize a system. Therefore, our company developed a precipitation platform. We call it NIRAWeb. Actually, this is a radar-based, high-resolution, precise forecast, and also using historical data. So it has a resolution of about 1 square kilometer and is updated in a sequence of 10 minutes. So it's a quite precise rainfall forecast. And it is permanently calibrated through ground stations to compare and getting the most precise results. This data can used for planning purposes if there are sufficient historical data available, but we use it also mainly to feed this information into the management software to operate the drainage infrastructure, for example, of a complete city. Now, if you look again at this slide with several levels, the crucial point is the information flow within these levels. The first one is the sensors in the tanks, in the retention tanks, in the channel, in the storage channels, information from treatment plant and so on are measured by sensors. So that means the actual status in the complete system is measured or is indicated. That is the actual status of the system. And secondly, from outside, the rain forecast, so the information through the internet coming in, the information of the rain that is going to come the next 6, 12, up to maximum 72 hours in advance. So these two informations, actual situation and the forecast, are putting together and evaluated in the management software. There is a process control as well as operation control, and also it can be combined with a OPC UA interface with a catchment simulation program. And then this information is analyzed and decide what to do and how to control the various objects and the equipment that sits into these objects, and then opening or closing a gate or a vertical lifting weir or whatsoever. Yeah. So that is the general flow. That means information exchange among the objects is very crucial and a very big advantage, and that is the new point. Usually, till now, in most of the structures, each object is more or less independently and statically controlled. But in this system, we call it IntelliNet. All these objects are communicating each other and exchanging this information. The reason for this is just to maximize the usable storage volume in the system, because sometimes in one area of the city there is the full capacity of storage has been reached, in other areas maybe not. So to manage it and to create overflows or flooding only if more or less the entire storage volume has been utilized. So this then is all controlled, monitored, and the operating is completely operated, the drainage network, in a central management platform where all this information is handled, managed, and analyzed and controlled. So the IntelliNet integrates the process control, a SCADA system, an operational management system, Canio, as well as the rain forecast in the NIRA-web software, and all integrated into one management platform, which is called the IntelliNet. So that is just now a very brief description of the software, the management software. And now I come to the second part, the smart machines that are able to receive and to use this digital system, digital signals. Okay, this is one more slide for the management system here. You see the visualization, analyzing, and rain forecast. You can see also visualizing cameras can be installed in the critical overflow points or any other structures. Yes, and here this is a map showing all these different objects. Okay, but now I come to the next point, the intelligent machines. Here, as an example, you see a rainwater retention tanks. There's a lot of equipment. It's not just concrete. I mean, in earlier days it was just concrete. In Germany, for example, still about 40% of the rain water retention tanks are just concrete. But now we retrofit this gradually to upgrade it and to make a higher degree of, or to reach a higher degree of utilization of the storage volume. So there's a lot of technical machines inside. I just want to pick out 3 or 4. The first is cleaning system to remove the sludge after emptying the tanks, which is quite important because it has quite an impact if these tanks are piling up and accumulating the sedimentations. So this is a jet cleaner that receiving information also from the rain forecast, and they know how much dirt load is going to come into the system, and then they adjust automatically their operating mode to higher or less energy consumption. Secondly, they are equipped with camera to indicate the areas where there is residual pollution and sludge, and just cleaning exactly this part, and they clean until the tank has been completely clean, and then they stop it. So it is a so-called result-oriented cleaning system. Yeah, it starts when it is dirt, and it stops as soon as it is clean. Secondly, this is a HSR, a so-called a CSO, combined through overflow screen that protects the receiving waters, rivers and lakes from floating matters that are common in combined sewer system. So they usually have a free space of 4 millimeters. Here you see they are installed on concrete edges and protect the emergency overflows. And the point and the new development is that the cleaning speed here, this is a hydraulic cylinder that cleaning continuously the bars, and they intentionally create filter carpet by the solids present in the water, and the cleaning speed is adjusted to maintain a certain filter and increasing the filter performance. So that is a significant contribution to retain the solids, and even the small cigarette butts or hairs or whatever kind of plastic is retained from polluting the receiving water. Important also in a system is the flow control. So these kind of hydromets flow controls are installed in different objects to avoid hydraulic overloading of critical sections of the system, and also to avoid overload of wastewater treatment plants. So they receive the information also digitally according to certain conditions in other places and other sections of the system, and then opening or closing the gates and allowing more or less water to flow downstream or to the pumping stations or to the wastewater treatment plants. So this is a significant improvement compared to conventional flow controllers. They are often just operating in a static way, just by buoyancy control or so. And the last example of a smart machine, intelligent machine, I would like to introduce vertical lifting wear. Here, that is the wear. It is installed in collector channels, for example, to control water levels and flows, but also can create flushing waves in channels to remove sedimentation. There's a wear plate. The point is that the wear plate moves down into the ground when it is open. So there is no obstacle in the flow path, and it is controlled by two sensors, level sensors upstream and downstream, and it can, on this way, control a preset water level as well as keep flows, preset flows, maintain flows in the system, and also can create flushing. That is, it can utilize and optimize the available storage volume in collector channels. So here, just a black and white picture of such a wear installed in a combined sewage system. So it's black and white because it's in the dark. And here, about a couple of 100 meters downstream, it creates a strong flushing wave to flush all the sediments downstream. It also can be installed as outflow controls, as a dynamic and real-time control outflow points, CSO points, compared to static concrete crest. It allows a flexible overflow from the collector channel into the rivers or into the receiving waters according to the condition in the collector channel, and of course also in accordance depending on the water level in the river. So this is a significant improvement compared to these fixed and static outflow points. So now, why to do all this kind of digitalization? What is actually the use of the digitalization, the objectives? So we're doing this, first of all, to increase the operation reliability of the system. I also want to mention that also in many cases there are maybe some changes in the system from the design parameters. So if we use digital and smart machines, we can compensate failures that has been done or differences that has been done during the planning phases. So we can optimize the flow, optimize the operation afterwards, so a higher reliability. Secondly, to increase safety and security of the assets, of the and also the humans. And finally, securing the investment and the return on investment, of course, because it's the taxpayers' money. So to summarize, it leveraged the value for the society in terms of cost and environmental protection. So finally, just whom to contact if you may seek some support or share the experience that we have been collected over the last 35 years. In Germany, for example, we were involved in more than 6,000 in the design and equipment of more than 6,000 rainwater retention tanks, and we're providing the complete products from the software, the IntelliNet that I just described, and all kinds of mechanical and technical machines sitting in the infrastructure. And here in Poland, we are working with our partner, Ecol Unicom. So thank you for your attention. And if you may have some more question or detail, please, you are highly welcome to visit the stand from Ecol Unicom, and we may discuss projects in more detail. Thank you very much.